Hi, everyone. This is Morgan here with Positive Approach to Math. We are moving right along in our algebraic expressions topic. We are going on to lesson 4, where we put the best of both worlds together. We put lesson 2, combining like terms, with lesson 3, the distributive property. So we're basically looking at an algebraic expression, so something with a bunch of terms, but this is a little bit more complex. It's going to have some parentheses involved where we have to distribute first, and then we will have to check and see if we can simplify by combining any like terms. As always, we're going to start with a little for your information, breaking down what we're doing here, giving you some concrete directions or facts, I guess you could say. Moving on to a bunch of examples, because that's where all the magic happens when you get to follow along and be a part of some problems. And then we will wrap up, summarize, with any helpful hints that you can take with you, put in your back pocket, right? And then I'll leave you with 6 problems to try on your own. So, beginning, we know that we have these algebraic expressions and we're going to have to simplify them, right? So, we talked about how you simplify by combining like terms in lesson 2. We look for things that have the same variable and the same exponent on those variables, and we add or subtract them. That is combining like terms. Then we talked about simplifying is we want to get rid of these parentheses. So the big distributive property, one of your most important things you're going to learn in Algebra 1, that is, you have to distribute when you see a set of parentheses and a number directly in front or directly behind those parentheses with no symbol in between. That tells you, aha, it's multiplication, it's the distributive property, and you distribute that number to every term in your parentheses. Okay, but now what happens when you see an algebraic term, or an algebraic expression with parentheses and then some like terms? You have to put the two together. And how we do this is we're going to look at the algebraic expression when we need to simplify it. We're going to say, do we see, it's like that game I Spy. Do I spy with my little eye any parentheses with a number directly in front and a number directly in back? If so, I'm going to distribute first, because I can't move things out of those parentheses until I shatter them. And the way to shatter your parentheses and set them free is to distribute that number in front, right? So we're going to do that first, because then I can move things and combine like terms. If I still have those parentheses, those things in there are stuck in there, and I can't combine them with anything outside of those parentheses by adding or subtracting. So we're going to distribute first if you see parentheses, and then we're going to combine like terms that we see within the algebraic expression. Just a reminder, as I say here, always distribute first, then look to combine like terms. And we really want to be sure when we distribute here that we're only distributing in the parentheses that number on the outside goes with, right? We don't want to just get distribute happy and distribute to every single thing we see. We only distribute to, if there's a number on the outside, you distribute that number to the things on the inside of that direct set of parentheses. So let's get to it. This is a fun one. So, first example here, we see, so let's look at this. We say, okay, do we see parentheses? And the answer is yes, I see parentheses. Now, I want to be clear that the number that's glued to those parentheses is the 3. Because look at that 3. It's directly next to those parentheses with no symbol in between, okay? That 15 on the outside that we also see on the outside is not glued to the parentheses because there's a plus sign on it, okay? So that 15 is just hanging out. It's saying, here's a thing, and then plus 15. No big deal. That's what it's saying. So we need to distribute this 3 to everything in the parentheses. And this is where I say don't get distribute happy and think, oh, I'm going to draw my arrows here too. That 15 is outside of the parentheses. So that 3 does not belong to it. We don't have to hug that 15. Like I said, that's kind of on its own little island, right? So what we're going to do is we're going to do 3 times 2x, which will give us 3 times 2 is 6, and then we'll bring down the x. Okay. And then we're going to do 3 times -4, which will give us -12. So remember, we're going to put -12 instead of plus a -12. And then we're going to say, oh, that plus 15 on its own, we can't leave it behind. We'll bring it along for the ride. And we bring it on down. So we shattered those parentheses. That is super important because now what I can do is I can look for like terms. Here I'll go backtrack to the original thing. You cannot combine these two things initially because that -4 is locked in with that parenthesis. So it has to tag along with that 2x. Until you shatter that parenthesis by distributing, that -4 is not free to move wherever. Okay, so now I'm going to say, okay, I got rid of those parentheses. Let's skim and go back to lesson 2 now and say, do we see any like terms? Do I see any other x terms? No, so I'm just going to bring that down. I see 2 constants, right? I see -12 plus 15, -12. Now we're combining like terms. When we combine like terms, remember, we are adding or subtracting. So distributing, arrows multiply, combine like terms, add or subtract. So we got to get that straight. So -12 plus 15 will give us a +3. So we'll combine that to +3. And as you see here on the screen, that 6x, I put an arrow. I like to make a mark on every term. So even if it doesn't have a like term, I draw an arrow or draw a line in a different color, just so I know I utilized it and everything. I didn't leave anything behind, right? We all want to go to our end destination. And so I want to make sure I bring everything there, right, to that journey. Okay. Next example, we see a lot of things not in parentheses. So we see a -2 plus 5. Rookie mistake number 1 that I see people do is they combine these two things, -2 plus 5, and they call it 3, and then they distribute 3. We cannot combine the like terms first. Those are not like terms because that 5 has a big thing in parentheses glued to it. So that's a major, major, major no-no, okay? The thing that we're distributing is this 5. The reason being is it is right next to those parentheses. There's no space between 5 and parentheses, right? So that tells us that's what we have to distribute. The things that are serving on their own island are -2. That's out on its own. And plus, because we see that separation with an operation, the plus sign, 3x. That's on its own. Okay, so they're separate for right now. We're going to take care of those parentheses. When we go to distribute, we're not going to get distribute happy and say, you get a 5, you get a 5, you get a 5, you get a 5. The only things that will get distributed by 5 are those things directly inside of those parentheses. So we're going to do 5 times x and 5 times -1. Okay, so here's my arrows, -2. You get to come along for the ride right now. Nothing we can do with you here. Okay, or yet. 5 times, remember there is a 1 in front of that x. 5 times 1x is a +5x, so I will put plus 5x. Okay, and 5 times -1 is a -5. Okay, that took care and it shattered my parentheses. And then this plus 3x, I will just bring that on down. Okay. Now, shattered our parentheses. Now we look to combine like terms. So I'm going to say, okay, my first variable I see is an x. I see 5x, underline, underline. Do I see any other x to the first power? I do. So I can combine them. When we're combining like terms, we're adding or subtracting. So 5x plus 3x will leave us with 8x. Okay. Now I will look for my constants. -2 is a constant and -5 is a constant. So -2 minus 5, I'm combining as I see it, they will combine to -7. So that's going to become 8x minus 7. So it looks really complex when we first looked at that algebraic expression, but it really was the expression 8x minus 7 in disguise, right? So we distributed, then we combined our like terms. All right, I'm going to have to slide this up a little bit. Okay, let's look at this third example. So looking here, a bunch of terms. Remember, do not think, oh, I can do 4 plus 2 and call that 6. Do not think I can combine constants first and do 4 plus 7 plus 1. All of those are major, major, major no-nos. You look for your distribution first. Look for your parentheses, and how you know what value to distribute is the number directly in front of those parentheses or directly behind without any plus or minus sign separating the number and parentheses. So here we are distributing the 2, and we're distributing it to the y and the plus 7. I know I'm distributing that 2 because there is no plus or minus separating 2 in the parentheses. That 2 is glued to that parenthesis. Okay. Standing on its own for now, we're not even going to worry about. We're just going to bring it along for the ride. 4, negative 5y, plus 1. All unique, and we'll just bring them down. And then we'll deal with combining like terms at the end. But let's shatter our parentheses first. So we're going to do 2 times 1y and 2 times 7. I will bring this 4 down. Like I said, I like to draw an arrow so I don't forget it or leave it behind. 2 times 1y is 2y. 2 times 7 is 14. I will bring down this negative 5y, and I will bring down this 1. Do not get distribute happy and distribute that 2 to everything. It's only related to those things in the parenthesis. Okay. Now from there, I will look for some like terms. So I'm going to look for my y's first. So I see a 2y and a negative 5y. So that will combine to a negative 3y. 2 minus 5 is what I did there. And then I brought the y down. And then I will look, I have 3 constants, 3 things without any variable. So I will do 4 plus 14 plus 1. So 4 plus 14 is 18. 18 plus 1 is 19. So that will become negative 3y plus 19. I worked just left to right on adding those. And as you can see here, I like to underline, squiggle, differentiate in colors each like term or each thing, so I leave nothing behind. So everything has a line, so I know all of those are taken care of in some capacity. If something didn't have a line or a squiggle or a different color, that means I must have left it behind, so I would still have more simplifying to do. The fourth example has 2 sets of parentheses, and that's not to panic. You just have to distribute twice. So this first set, this 4 goes with this set of parentheses. And then you see this negative 3, it goes with the set to the right of it, or the set of parentheses to the right of it. So we're going to have to distribute twice here. So we're going to be doing 4 times 1h, which is 4h. Remember, there's an imaginary 1 in front. And 4 times negative 5, sorry, I should say an invisible 1. 4 times negative 5 is negative 20, okay? Now we're going to distribute negative 3. So we're going to do negative 3 times 2h, which will give us negative 6h. And then we're going to do negative 3 times 6, which will give us negative 18. Now, before we wrap up this problem, we're going to make sure and check to see if we have any like terms. So I see a 4h minus a 6h. Those are like terms. They both have the variable h to the first power. 4h minus 6h is negative 2h. And then we have some constants. We have negative 20 minus 18. So remember, when we're combining like terms, we're adding or subtracting. So we're doing negative 20 minus 18, which will give us negative 38. Cool? And last but not least, I just needed to touch on something that might pop up, and I don't want you to panic when you see it. So, first and foremost, the thing that we are distributing, if I were to ask you right now, I would say, okay, what value are we distributing to our parentheses? I hope you can repeat back and you could answer me and say 4, right? Not the negative 4W. This 4 is glued to that parenthesis. There's no symbol in between. And this guy is kind of out on its own. So that's just going to come along for the ride. We're going to distribute 4. There is a 1 in front of that W. That gives us 4W. And then we're going to do 4 times negative 5, which gives us negative 20. And then we're going to bring down negative 4W. Nothing was left behind. We took care of each term. And now we're ready to combine like terms. So I see that I have a 4W here and a negative 4W. So when I go to do 4W minus 4W, I get 0W. Okay? And then I say, okay, that constant doesn't have any friends. So it's just going to go along for the ride and we're just going to bring it down. Now here's the situation. You will never see an answer look like 0W minus 20, right? Hopefully you know that any number times 0 is just 0, right? So when we see 0 times W, 0 times W is really just 0. So 0 minus 20 is just negative 20. So you're not going to actually see that 0W written. You're just going to see your answer as negative 20. Okay? So whenever you have something adds, when you're combining like terms and something adds or subtracts to 0, you don't have to write it because 0 minus 20, you would combine that to just get that negative 20 then. Okay? So just a little reminder, 0 times any number, we'll use the number symbol, is just 0. Okay? All right, that we went a little bit slower with, but I think it was super important to break down because, like I said, you don't want to get caught making any of those rookie mistakes, combining things before you distribute or distributing the wrong thing. All right, some helpful hints as we wrap up here. So whenever there is a number directly in front or behind a set of parentheses with no operation in between, that's important. The distributive property will be needed. And you know, when we say distribute, we mean we multiply. Okay? After you distribute, always check to see if there are any like terms that will allow us to further simplify. Remember, when you see that word simplify, it's telling you distribute, combine like terms. Okay? And finally, what we just saw in our last example, if something adds or subtracts to 0, it does not need to be written. So we're not going to actually write 0W. We're going to say 0 times W is 0, and 0 minus 20 just leaves us with that negative 20. So I did leave you with 6 you try problems for you to try on your own. They look good. Number 6 is a fun one. Please feel free to try them on your own. I encourage you to try them on your own. I know you can. At least get started with some of them on your own. And then a link's popping up for you to click on to check your work. And if you're a little reserved and think you might need a little extra help, or you just want to go through a couple more, you're second guessing yourself, the link below, the answer key, will provide you with a video where I go through each and every one of those 6. No big deal. All right. Keep up the great work. We've got one more lesson in our first topic. See you soon.